Okay, so now just we are moving ahead the continuous cooling curve and interpretation of the final microstructures. Okay, so here we are having the continuous cooling curve. So I mean, previous we were discussing the time temperature transformation, which is isothermal transformations. Continuous cooling transformations diagrams are used to predict the microstructures and properties of a steel when it is cooled continuously from austenite phase at a various cooling rate. Unlike the isothermal transformation diagram, which assumes the constant temperature conditions, here you can see that CCT diagrams reflect the real world cooling sense scenarios such as air cooling, oil quenching, water quenching. These diagrams are essential for the designing heat treatment process and predicting the final microstructures and mechanical properties of steel. So now you can think about what is the difference between the CCT and TTT. So in TTT, we are having the isothermal process where we say the constant temperature predict. Here we are the in CCT diagram, the real world scenario, what happening in the real conditions like air cooling, oil quenching, water quenching, how they are just behaving. That is all coming into the picture inside the continuous cooling curve. Okay, and these diagrams are just essential for designing the heat treatment process and predicting the final microstructure. So all the diagrams, just we are able to know what are the microstructure that we are getting from heat treatment. And once we know the microstructures, then we can conclude their mechanical properties. And after knowing the mechanical properties, that we are having a idea that where and how we can apply this material into the applications or for a particular applications. So these are the just kind of things you must have into your mind so that you could write a good way in your answer. Where we think, I mean, if you are just writing something, then you can mention these lines of kind of why we are just studying. So you have two or three lines memorized in your head. So then you can write, okay, so we are interested in microstructure. We are interested to knowing the to know the microstructure of a material during the heat treatment so that we can have idea about their mechanical properties on the basis of microstructures. Okay, these are just the diagrams. Here you can see similar to that of the previous one, but here is a continuous, right? Means you can say it is a kind of for the quenching and for air cooling, or you can say the normalizing. But in previous we were having a furnace cooling, or you can say the annealing. Okay, so whatever the you can just differentiate during the annealing, whatever the temperature curve that we are getting, that is the isothermal isothermal temperature isothermal transformation, right? And for normalizing, or you can say for quenching, that we are having the CCT. Okay, so for the TTT that we are having on annealing, and for the CCT we are having quenching. Okay, and normalizing.